Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badruddin and today we are going to solve the last lab from OAuth authentication vulnerability module from proxy. So in this lab we are gonna steal OAuth access token via a proxy page. This proxy page is very important and we will see that in a minute. This lab uses an OAuth service to allow users to log in with their social media account. Flawed validation by the OAuth service makes it possible for an attacker to leak access tokens to arbitrary pages on the client application. Now, to solve the lab, we need to identify a secondary vulnerability in the client application and use this as a proxy to steal an access token. So this lab is very similar to the previous lab, but there is only one difference. In the previous lab we found the secondary vulnerability as the path traversal, and then we also found open redirect. So we steal the token via open redirect, but here we will use proxy page as the secondary vulnerability. We will chain a bunch of vulnerabilities here, and directory traversal we will also see. So we will steal the access token of the administrator account. Now then we use this access token to obtain the administrator API key and submit the solution using the button provided in the lab banner. The administrator user will open anything you send from the exploit server, and they always have an active session with OAuth service. So for CSRF, it is very important that the victim has an active session. So you can log in via your social media account, and we have credentials. These are the credentials. As the victim uses Chrome, we recommend using Chrome browsers or Burp Suite built-in Chromium browser to test the exploit. One thing before jumping to the lab, which is this particular lab, I already tested it on the Mozilla Firefox, and I solved this lab in Mozilla Firefox with facing bunch of difficulties. So for the smooth experience for you to walk through this solution of this lab, I would highly recommend you guys to use the updated Google Chrome browser. If I go to the help, you will see here that my version, this is the newest version. Fine. So let's go without wasting time. I'm directly going to jump to the lab. So X is the lab, and you can see we are getting hits here on the burp proxy. So how I'm getting these hits on the burp proxy? Because I open the Google Chrome browser by this approach, Google Chrome with --no sandbox, and specifying the proxy server parameter and providing the value of the proxy, burp suite proxy. Fine. So here we go, and we have the lab now. So I'm directly going to log in. So if I go to click my account, it's gonna redirect us to the social media, and here we need to provide the social media credentials, which is Wiener, sorry, WIENER Wiener, and the password is Peter. Log in. Once I try to log in, you can see this was the very first request, and if you see this request, you can see response type is equal to token. That means implicit grant type is being used, and once I provide the consent to the third-party application, okay, you can access my information, profile information. You will see that we can access to the profile information by using that access token. Fine. So the first very important thing here is, if I go to my account, you can see the API key is not visible here. So second thing I can say, if I log out and go to the my account, this time you will see here it's redirecting us to the social media, and then directly go to the OAuth API service, and then it's directly take the access token from that service, and it's accessing the profile information. So in between there are a bunch of processes which already done here. So in the second time you will not see all of those requests, because you already provided the consent to the third party application to access your profile information. Fine. Okay, now I'm gonna take this request and I'm gonna send it to the repeater, back to the repeater. And here, if I send this request, you can see 302 found. What we tested before in the previous labs, that we try to exploit this particular parameter redirect URI to actually test any out of band interaction or in band interaction, whatever. So here also I'm gonna just test whether I can interact with any other websites or any other sites or any other domain. So I put here example.com, and as you can see, 400 bad requests. Even if you try the exploit server URL, if you try to access the exploit server, instead of that, it's also not gonna be accessible. Okay, send the request again, and what is that? I did something wrong. Wait a moment. Just Control Z, okay, and Control V. Is that okay? Yeah, now it's okay. So send the request and 400 bad requests. That means you cannot access any other site from here. So back to the genuine request, which is this, containing the OAuth callback. And I'm not going to very much detail because this part I already explained in the previous lab. So I'm just going to try that part with directory traversal. So I just added here one path above to that particular directory and try to send the request, and as you can see, 302 found. That means directory traversal is there. Now we need to find out another vulnerability, because this is a lab and it's already mentioned here that we need to find out some secondary vulnerability which we can use as a proxy page. But in real world scenario, maybe you take 1 hour, 2 hour, 5 hour, or a day, or maybe 2 days, 3 days to find out the secondary vulnerability or any other vulnerability. So make sure you do not skip anything that is very necessary, and make sure you stick on the fundamentals, which is enumeration is the key. So what I'm going to do here is let's go, and I'm going to try to access any post here. And once I try to access any post, you can see this is the request with which I'm trying to access the post or blog number 10. But one interesting thing here, if I scroll down, you can see similar to the previous lab, there is no next post option. So you cannot switch from this post to the next post directly where we found the open redirection. But one thing is interesting here. If you see these requests, you will find here one request which is post, comment, and comment form. So this comment form itself, these words are saying that this belongs to this particular form, where if anyone wants to leave a comment on this particular blog post, they can post their comment here, and this form belongs to this request. Fine. Now if I analyze this request, what I can see here is there is a script in the response. What this script is all about, you can see parent.post message. So if I see this script, and in a high level overview, if I give you, so this script seems to be facilitating communication between an iframe and its parent window, likely in the context of embedding a form or in a web page. So, and if I go line by line, so you can see here this particular portion. So the message has a type of onload, because onload function is being used, and it contains the current page URL. Fine. So you can see window location.href, that means any domain can be allowed here. So this star or asterisk indicates that the message can be received by any origin or any site, and this could be a security risk, and this is the place where the vulnerability exists. Now Here in the next line, function submit form. So a submit form is being created, which is gonna prevent the default submission of the form data. Fine. New form data has been constructed here for the comment form, and this comment form is basically this endpoint. Okay, so if you go here in this particular page, and if you try to see view page source, and in the last, in this section, you will see one iframe, and the source is this post, comment, and comment form. One thing is very interesting. If you just click on this, you will see only the comment form, not with the blog post. As you see here, this comment form with rest of the blog content and rest of the comments, but basically this one is here is a separate iframe. Fine. So back to the burp proxy, and now it's here. This line is also interesting. If you watch the previous lab, you will know this window.location.hash.substring1. So that means it is gonna parse the URL after the hash, whatever value is there, it is gonna parse that. Here it is gonna gather all the form data, okay, with the ID of comment form, and from here it is gonna extract and parse any URL data after the hash. Okay, this we already did before. Now here you can see another variable is being defined, which is O, and here it construct the form data. Okay, and now at last it is gonna call this parent.post message, and then on comment it is gonna send this to send the collected data to the parent window with the message type on comment. Okay, so this is what this script is all about. This particular object O is actually merging the form data and hash parameter into a single object, which is defined as O. Okay, so that is the thing. Now what we need to do here is, I'm just gonna try that particular thing, that particular endpoint into the repeater. So after this directory traverser, I'm gonna paste that /post/comment/comment-form, and let's send this request. So as you can see, 302 found, and you can see within the response in this location URL, you will get, within the URL you will get this access token. So let's see, I'm gonna close this, okay, and just manage this a bit. This is our exploit server. What I'm gonna do is I'm going to create one iframe. What is that? What's happening here? Okay, now it's fine. So /iframe, and here also I'm going to define iframe with the source is equal to, and this source is going to be this URL. So I copy the URL and paste it here. Now the thing is, we will send a malicious link to the victim of our exploit server, and once the victim will access that exploit server, this iframe will be loaded, and it will load from this source. Okay, and it will help us to generate the URL which contain the access token. And then we need to, once you see this request here, you can see it will take this section, which is specifically after the hash value of that URL, which contains the access token script, and then I'm gonna say window.add event. So I want to add a listener. Okay, and within that listener I'm gonna specify message, and then I want to specify one function, let's say e or whatever, and again I'm gonna say here let's say false, and within this I'm gonna fetch it. Fetch what? Fetch from the existing domain root directory, and I'm gonna add here encode URI component. Okay, and then e.data.data. Just a moment, let me just write it, because I'm not good in speaking while writing, so please bear with me. And that's it. Now what I'm trying to do here is this script basically just wait, I forgot to end up the tag here, script tag. So this script basically listens for messages sent to the window and make a fetch request, which is this one, based on the received data. Fine. So here this window.add event listener, what it's doing, it adds an event listener for the message event, and this is going to be triggered when window.post message, this one, where is it, post message. Okay, so when this post message is called from another window or iframe, so when it is called, this is going to trigger. Then it will make a fetch request to the URL composed of the current domain root directory, okay, which is this one, and it is gonna add here the URL encoded data property of the incoming message. So that's it. This is only the thing we need. Okay, so what I'm going to do is to store it, and after storing I would like to first of all test this exploit. So before sending the exploit to the victim, we must be sure that it's gonna work fine. So view exploit, and if the iframe window is correctly loaded, then it's working fine. Let's see. I'm going to access log, and if we get the data of within the access log, then it's perfectly fine. And as you can see, it's getting the whole URL with the access token. So this is the access token, and %3d means equal to, and after this is the access token, but this access token belongs to me. So I'm going to copy it and test it. So to test that, we need to find out /me request, which is this. I'm going to send this request to the repeater, and you can see here this is the access token belongs to us, but every time you will get the new one. So I'm going to paste the new one, which I just copied from the access log of exploit server, send the request, and you can see we are successfully accessing our information. But this is our access token, no benefit. We need the victim access token. Now it's very easy because the exploit is working fine. So just deliver the exploit to the victim. Okay, and go to the access log. And as you can see, we see bunch of different IP request, and here you can see this is the URL with the access token, and this is equal to sign, the URL encoded value of equal to sign. What we need from here is this access token. So from T up to C, because this %26 is ampersand URL encoded value. So I'm going to copy that and go back to our website, and I'm going to change again this access token, paste that. So it started with T and end with C. So it started with T and end with C. Okay, fine, and just send the request. Invalid request, invalid authorization header value format. So there is something wrong. Let's see. Back to the exploit server. Okay, source, I think this is perfectly fine. Let's see, view exploit. Okay, it's loading fine. What we did wrong. This is what we got. Back from here, deliver exploit to the victim, and just try to access the logs. Here again we get something, and up to here, this is gonna be our token. Back to the repeater, and oh, come on. Oh my god, everything is fine. Actually, I did a mistake here. Once I try to delete the access token, I also deleted the bearer. So it should be deleted only up to here. And come on now, paste the new one, which is this. Send this. We should get the response. Yeah, administrator is the user, and this is the API key. I'm going to copy this back to the lab and submit the solution. So that happens sometime. Okay, so that's it. The lab is solved, and I think you enjoy the lab. So if you like the content, please like, subscribe, and share, and I'm gonna see you in the next video. Bye.